after I've gotten my inventory of the system and know how it's put together, in particular the overhead of trying to figure out file system layout and alternative paths and failover paths to my spindles, the second thing that I really should be doing is establishing my metrics. Now, I flip the modules around in the workbook for time reasons because I always, as a milestone, want at the end of the first day to have PCP and SAR data working. So just kind of flip the modules around for time reasons. The bigger the system is, the more accountable I am for it. I need to talk about just the effect of measuring the system. It's entirely possible that looking at the system affects what I'm looking at. In particular, S-trace can do that to me. Perf can do that to me. There are a lot of things where the side effects of the instrumentation can be worse than the original problem. Primarily, I want to talk about SAR and making sure that that is on. And then primarily, I want to get into pmlogger and start collecting PCP data. I am not going to cover CSA accounting in this class. I still leave it in the workbook because I still use it and still have occasional customers that use it, like NASA. But for time reasons, I am not dealing with CSA accounting right now. So looking at the system will impact the system. The tool with the biggest impact is S-trace. If I'm doing 100,000 calls per second, S-trace is going to have an impact on that. By the way, there is a GUI for S-trace called the Linux Trace Tool, LTT. We integrate that on our React distribution, but you can also grab it off from SourceForge or someplace. Now, S-trace, when attaching to a process, can generate a lot of data. If I'm doing 100,000 calls per second, that's going to be a lot of data that's thrown out there by the S-trace information. People that use S-trace, the first thing you got to realize is you need to skim read it. Don't read it line by line. Don't get stuck between the lines. You need to be able to look at, 200-300 lines at a time before you narrow down what you're looking for. Second thing is, when I attach to a process that's doing I/O, and now I'm S-tracing all those I/O operations, the I/O intensity, the number of I/O operations per second, is going to go down. And that can impact my ability to look at a problem. So I might have a problem where the application is dominating memory, doing a lot of writes or something like that, and that thing having a high I/O intensity is dominating my system. Once I attach to it with S-trace, it throttles back the intensity of the I/O operations, and my problem goes away. I've seen that happen in my training classes numerous times. Another thing that can have an impact is profiling. I can profile safely, like on a small CPU system, but then I might go, for example, a class a couple weeks ago, I was doing 4 threads wide, and then I went to 256 threads wide, and the interrupt handler time for handling all the profiling went crazy. I intend to try to replicate that this week and get interrupt handler time too high. Accounting data. Accounting data itself is always on. The get delays and the data that CSA accounting gets to is always there. All CSA accounting is doing is writing it off into the file system. So the penalty with CSA accounting, number one, is the size of the files. And in fact, last week when I stopped at a site, the PCP data was too large of a file because they were collecting disk activity, and they had 1,400 paths to the disks. And they were collecting quite a bit of data on a per-day basis. So being able to take the accounting data and consolidate it down is something called CSA run. And that overhead will show up in your accounting reports. Just turning on accounting does not cause more system time or more user time, but it will cause some I/O pressure. It will cause I/O large data files to be created, and you can throttle some of that back down if you know how to use CSA. The main command is a command called CSA build that will take the per process records, sort them, and consolidate them. And if I got 1 million records to sort and consolidate, that can take time. PCP and SAR are the lowest impact. In fact, SAR is lower impact than PCP. When I'm looking at data, there are two ways of looking at profiling. One is sampling versus block counting. With sampling, I'm periodically checking to see where the program counter is. With block counting, I'm adding code to my executable. So when I compile it, I can do a -profgen that's going to add code to my executable, which means I'm running more instructions, which means it's going to slow me down. Second way of looking at data, frequency versus time domain. When I'm looking at SAR and PCP, I'm looking at how busy it is or how many calls per second, some sort of rate type of information. That doesn't give me performance. There's nothing in SAR or PCP that gives me time to solution. So that's why I'm going to use the time command tomorrow. I will install CSA and use that a little bit. And also getting into the PBS accounting data. Everything I'm trying to do is get from the frequency domain to the time domain. So if this thing's running for 8 hours, I want to know what it did for that 8 hours. Was that all user time, system time, IO wait time, trim wait time? What was queue wait time? What was that wait time about? Third method of getting data, development versus production. When I'm in a development environment, I'm going to use profiling tools. When I'm in a production environment, I don't profile anymore. If an event is occurring, then I might kick in some profiling tools. In the development phase, which we're going to get into Wednesday, we're going to start using PAPI, Performance API. It's been around for a long time, but it's been integrated into Red Hat and SLES. It's a standardized interface to get to hardware counters. That'll be Wednesday's topic. Also use perf quite a bit. The example I just had with that system time, the only way that I would have been able to see that that system time is from compaction or garbage collection or coalescing the slab was to do a perf record -G. That's the only way I would have been able to nail down that system time. Otherwise, I just would have saw that raw spin lock routine, but not what called it. So with the call tree, stack trace that I get with the -G, I was able to see the memhog take a page fault and that drop into allocation, and then allocation drop into compaction. And then the compaction calling me the lock spin lock routine that I saw there. Only perf-G would have gotten me there. There's also PS run that we'll be using Wednesday, and strace. I'll be using strace a little bit as well. Also, those are getting into hardware counters and subroutine lines, but also my elapsed time components coming out of CSA COM, or if it's LSF, it's BAC, or PBS report if it's PBS Pro. So, getting the data. There's a lot of data in large environment. I've been looking at SAR data for about 30 years. 10 minutes is just the right sample. Best for daily, weekly, monthly. Your cron events, by default, will be 10-minute samples for your SAR data. If an event is occurring that I want to drill at more closely, I might go down to 1-second samples. But too tight of an interval can collect too much data. There is 86,400 seconds to a day. That's a lot of data. 1,440 minutes to a day. That's a little bit more easily tolerated. And again, if I had 1,400 drives and I'm trying to get 86,000 samples during the day, my files would get too big, too far out of control. So what's my sample interval? If an event is occurring, I like 1-second samples. I'd like to do that 1-second sample for like 5 minutes and collect the data for a 5-minute window to look at what's going on. When I'm doing baseline or long-term, I like 10-minute samples. And then I do want to get into being able to look at a day's worth of data, a week, or a month. And things like Ganglia can put into place so I can look at quarterly and yearly. And I do know of sites that plot CPU utilization, for example, for a 5-year window. Now, Ganglia does something called RRDS, a round-robin database type of thing. It will reduce the granularity of the data after a while. So for today, I might get 10-minute samples, but then if I try to look at last week, I no longer have 10-minute samples. That keeps the size of my data set down and manageable, and then I simply have a summary for each day rather than a 10-minute granularity. Now, getting through a lot of data, I have to be able to throw data away. Anything that is less than 1% of what I'm looking at, I just put aside. Also, it's hard to deal with accounting data, but I need to consolidate my accounting data down to user or group. I want to do it by command name or by functionality. Category would be like a ledger account name. I don't know if you've ever used Quicken or MS Money, but if I write out a check, I'm going to have a memo thing, and the memo thing might say, I spent money at this grocery store, but it's going to go into the category called food. So I might have 10 different gas stations I go to, but they all go into one category called gas. So category is basically by functionality. And then classes is by resource consumption. So I might look at my data and find I've got big CPU, small memory classes, or big memory, big CPU classes, or big memory, big I/O classes. Classes is by resource consumption. So if I go through all my accounting data, I'd like to get my top users, top commands, what functional areas they are, whether we're talking compilation or maybe the categories are weather, astrophysics, and mechanical engineering, something like that. And then classes is by resource consumption. That's the hard part, taking a lot of data, take a month's worth of data and be able to consolidate that data down and get a meaningful interpretation of that data. So the first tool that I cannot live without, SAR. SAR gets automatically loaded when you install foundation software. There's an RPM SGI-based configuration that will load the systat RPM and turn SAR on. Now, SAR tells me how the system is behaving with the workload that's running on it. It's going to tell me about normal or abnormal behavior. So SAR can imply a performance problem, but does not indicate the effects of resource managers. I might be doing very poorly because I'm on a node that's out of memory, and somebody else is doing very good because they're on a memory node that is lots of memory available to it. So SAR, some systems, some users could have good response, others may have bad. Again, I like to think of SAR as my inkblot test. I put on 3 hats when I'm going through the system. The first hat I put on is a shrink, a psychologist, a therapist. You know, the old inkblot test. Are you crazy or not? So if every time I look at Dave Wright and he's busy doing work, and I do that every 10 minutes for 24 hours, and every time I look he's working, I can look for particular behavioral problems like stress factors and things like that. So based upon how busy different resources are, I can look for different types of behavioral problems. SAR will also tell me where do I start and what do I look for. So I just went through a high system time interval, and I could drill down into that to find out what that was. But SAR does not give me quality of service. SAR is health of the system metrics. How healthy is it? Accounting is what gives me the time domain. So it's the only place where the time for a process is kept. And if I have CSA accounting, I can also track CPU weight, trim weight, swap weight, disk weight, things of that sort. So I can have good SAR data and bad performance, and bad SAR data and good performance. I will demonstrate both. In fact, recently we had good SAR data, but when I tried to run Zipper or tried to do things that were metadata intensive, the slab was in pressure, the metadata was under pressure, and that slowed things down that would have required me to get to the slab. And again, I had bad SAR data a minute ago with that high system time, which was all compaction. Bad for memhogs that were trying to get memory, but I did not feel the impact interactive. I was still good performance interactively, except when I turned off fragmentation or defragging. Now, Performance Copilot gets to the same statistics as SAR does, and as well as more. So PCP gets to a lot more statistics than SAR. And PCP has GUIs to it. There are some GUIs to SAR data as well that I want to show you. So everything, whether it's PCP using PMCD, TOP, BMStat, or SAR, all go to /proc to get their data. I tell people in the class, I don't care what tool you use to get to the data. I'm going to use PCP because that's what's there, and I like it. But it's the interpretation of the data that I care about in this class, being able to look at /proc data on its own, like pmminfo. So, by default, there's a cron event that runs a script SA1 every 10 minutes. That thing fires off SADC, System Activity Data Collector. It's going to read data out of procstat, pmminfo, procdisstats, procvmstat, things like that. And it's going to generate a file, a binary file in varlog SA with an SA date on it. That's a binary file. Now, there is a sysstat file I'm going to have you change. If I increase the history to 28, then it's going to create a directory with the year and month in it, and then the date within that year and month. And there will be a link between the two files. Now, when I just type in SAR, it automatically goes to this file. If that cron event isn't occurring, then SAR is going to say there's no SA file there. So if SAR is loaded, you simply haven't rebooted since it got loaded, and there's a boot.sysstat that can start it. Now, there's also a cron event that runs a SA2 script and converts the binary into an ASCII file, so there is an SAR file. I myself don't care about the SAR files because I can't plot them, but I can plot the binary files. Now, if an event is occurring, I can go live. So if I just type in SAR, I'm going to a binary historical file. But if I type in SAR 1:120, the first number is the time between samples. So I'm saying collect 120 samples for 1 second. So over the next 2 minutes, collect 1 second samples. Trouble with that is that I can't see everything at once. So a better way to do it is a SAR-O, dump it into a binary file. So now I'm getting 120 samples into that file. And now with SAR-F, I can go back through that file and look at the different statistics. Let me demonstrate what I mean. I'm going to share my desktop. Let me go to Floyd 1. Hang on. I don't like that window. Let me get a better window. So, topology. I've got 32 CPUs, 2 blades, 128 gig of memory. I've got 2 disk drives. A is my root, and I have a data 1 there. And B, SDB, is a scratch file system. By the way, I want to check something here, -IH. And I've got 4 million inodes on scratch right now. I am about halfway through the number of inodes that that file system can hold. Okay. So what I was trying to demonstrate, I can do a SAR 1:5. And I can look at what's going on here. Oh, I do have some IO8 going on in here. Waiting for that sample to finish. Let me do a top here. So I can see the IO8 here. I'm going to do a I option here. Can't really see the IO8 yet. I'm looking for a WChan field or something. Let me come back to that. We have some D's and stuff like that. Trying to find out what that IO8 is from. Let me do a PS-EL. I'm going to pipe into more. I'm looking at the WChan field here for an IO8 type of event. There's one. This particular program here was sleeping on I/O. In fact, I can't exactly catch that thing. Let me do a ps-e-o cmd, wchan, and grep for sleep. And there I can see this thing is sleep on wait. I'm kind of jumping ahead, and I'm going to get back into this. But I was seeing with SAR that I had some IO8 going on, and now I can see at these code 5s that are in an IO8. Now I need to go root here. I'm going to echo a T into /proc/sysrq-trigger. Now while that's happening, let me go back here. So SAR 1-5, I can only see one thing here. If I do a SAR-A for everything 1-5, problem is I'm not going to be able to read this very well because it's all intermixed. So it's kind of hard to pull apart that report and figure out what it's doing. So now if I do a SAR-O, I'm just going to call it SA file 1-5. So now some event is occurring. Now I can do a SAR-F, SA file, and now I can see there's my CPU utilization, there's the IO8 that we were just seeing. But now I can go back and look at other things like -DP. Oops. Disk SA file. And now, for example, I can actually see from that interval I've got SDA being busy and SDB being busy. Actually, B is not busy. It's all on A. Everything I've seen here is A. My root drive that's busy, and B was not. So by using that -O and -F, I can save a file off and now look at other things, SAR-R-F SA file. I now have the ability to go back through and dig through that file. So here's my total memory, 131 gig. Looks like I got 800 meg being used, less than 1% being used. I have 100 meg of raw I/O in buffers, and I have 65 meg in the cached field. Now, I did an echo T. Let me go back to bar log messages. And let me try an IO_sched. And there we are. That code 5, I saw in top, I saw in SAR, 4% wait I/O. I then went with a wchan event and saw sleep on page. Anything that is counted as an IO_sched kernel lock, that's a sleep lock, will get counted as IO8. In fact, I can see here this is an NFS write going on with this particular situation, which means it's probably going to the home directory, and I might be in trouble here. And here's another one that was doing an NFS file write, but this one was sitting on a different lock for metadata. Mutex locks. Only IO_sched. Let me try that again. IO_sched is going to show up as an IO8. Let's see, that's PID 5824. And during that snapshot, I only caught one process that was sleeping on IO8. And doing an I. So all these Ds are part of the load level. And then I also have IO8 showing up here as well. Let me wrap up here. So I was just trying to demonstrate, and in the process I saw some IO8 and actually drilled into it. But SAR-120 can only show me one thing at a time. If I do a -A, it's impossible to read. But if I do a SAR-O, then I've got one file and can go back and look at the different statistics that are available in it. So, SAR is part of the systat package. There is a boot.systat flag and a service to start it. It's going to create a link from the systat.cron file, and the boot systat start is what creates the link for the cron event. By the way, I need to warn you, partitioning. When I repartitioned my system over the weekend, I changed the number of CPUs, and then the SAR binary file is corrupt. So if you are working in a partitioned system and you've changed the partitioning, changed the number of CPUs in it, the binary file will not be able to handle that. You'll have to remove the older file and then start SAR again, start the SADC cron event again to be able to get good data. So here I'm seeing in the itsy-cron.d systat cron tab for SA1. And by the way, it's doing in -S all, which is going to track all my disks and everything. You might want to turn that off. That will save disk space. And then here's my SA2 for the ASCII report. Now, during the boot process, you'll see it's run the SADC script. And if there is a lock file, this is the single thread, the SADC command. And if that existed from before, for example, cron event fired off, SAR was running, but it got stuck on a lock, and then the system panicked or took a service interruption, that lock file is still sitting there. So during reboot, it will spend about a minute and then remove that lock file. Also, I need you to edit. This is the important thing for me. I want to make sure that you get the systat history variable set to 31. By the way, if I am on Red Hat, it's an itsy-sysconfig, not itsy-systat. I don't like the way it is on SLES where they put it in systat. It should be an itsy-sysconfig. Also, again, check the cron tab for SA2. Almost done. Configure PCP. Now, I'm going to already have it on, but check config PCP on and check config PMIE on. I'm going to demonstrate this tomorrow. I'm not going to do a demo on this right now. But I need both of you, all of you, to be aware with the last November's release of SGI Performance Suite 1.5, we went to a newer PCP-based distribution, and there is now a pmlogger on. I don't know if that's in your lab procedure yet. Let me check something here. So this is more of the way IRIX worked. I just want to see if I got it in there. Yes, on my version of the workbook, yours should still be coherent with mine. On page 3-4, there is a new step there to check config pmlogger on. Otherwise, you will not get PCP statistics. There will be no pmlogger. So one of the things you're going to do here, you're going to go in and edit this control file and uncomment it to point to something like this. Then you're going to drop in a config file from my tarball for the class and put that into a varlib pcp config pmlogger type of directory. Then I'm going to drop in a cron event, change the permissions on the cron event. Here's where I'm copying in the statistics I want logged, and then I got to do a check pmlogger on, and then I restart PCP. So watch for that. That is new. Oops. That is new with the latest. The check config pmlogger on is new with the latest PCP and Performance Suite. So You're going to edit a config.default. In my case, I'm just doing config.sysa for a different naming scheme. Then I edit the control file, and I got to be able to uncomment the one line I was just showing you. And this slide needs to get updated, but I need to check config. Oh, it is already updated. Check config pmlogger on. And then tomorrow, I will talk about the alarm mechanism and PMIE to set off our alarms. And there are 2 cron events as well to check to make sure pmlogger is always up and running and that pmlogger daily cleans things up. Now, word of warning, ESP, Embedded Support Partner, used to make sure that PMCD is always up and running. With ESP gone, there is no cron event to make sure that PMCD is up and running. I do have a cron event of my own that goes back to IRIX days to check to make sure that PMCD is running, and if not, restart it. That's one of the pieces missing with ESP gone. So after I've done all that, then I restart PCP. No reboot is required. I also want to start PMIE. I will get to that tomorrow. So when I get a system, and by the way, PCP can run on Windows, it can run on Mac OS, it can run on Solaris, it can run on Debian. I have PCP on my Windows system. I could look at Windows, but actually I'm looking at the UVs. In order for it to look at the Windows system, I need a batch script that's going to start PMCD. But no matter what system I'm looking at, a pminfo-t will tell me what metrics I can get to. I advise you to print it out and learn what the groupings and the metrics are. We're going to go through maybe 60, 70 metrics that are in that list. Now, PMCD has to be running for pminfo-t to give you anything, and we can add to the statistics with what are called PMDAs, Performance Metric Domain Agent. A couple examples, I can add in XBM statistics, NFS statistics, there is luster statistics, InfiniBand statistics, things of that sort. Now, when you get into lab, there will be a config.sysa that you can grab out of the sysa labs tarball. And I'm just showing an example one here. I'm going to drop it into the var lib pcp config pmlogger directory. In this case, I'm using config.default, but in lab nowadays is using config.sysa. And when I start up the PCP, I'm going to collect the number of CPUs and the number of disks. And then every 10 minutes, I'm going to collect CPU utilization, load level, context switching, memory use, and swap information. I would collect a lot more, but this was just for demonstration purposes to fit on the slide. I also have access control information to be able to get to PCP data. So PCP has PMCD running. It reads data from /proc. There's an ASCII tool, pmval, that can show me the value in ASCII. There's an extremely useful tool, pmgsys, and that requires X11. And then tomorrow, and I already demonstrated briefly today, pmchart. And tomorrow will be all analysis. And I'm going to add in additional statistics, including UV statistics during the week. There is a bug on UV2, such that the PMDA for the UV2, there's a patch for it. They basically cloned UV1's performance metric domain agent and did not change the index numbers for the domain statistics. So if you're on UV2, there's a patch to get to the UV statistics. Also, PMIE is reading statistics there, and there is a PMIE config default that says set off an alarm if a metric goes above a certain threshold. Let me save that for tomorrow. But the alarm that gets triggered will write something into var log messages. In the past, ESP would see that message and then could take action on the message, for example, set up a pager if a file system is filling up. Also, I will review and demo this tomorrow. I am wrapping up for today, but the pmlogger command can be used for archives. One of the things I do not like about SAR is it does not separate my pmminfo. SAR will not tell me how much dirty data I get. It doesn't tell me how big my slab is. So the only way that I can see what dirty, write-back, NFS unstable, slab, and anon look like is by running a pmlogger event. So I'm having you drop in a config.sys to collect data. There will be a cron event to make sure that pmlogger is up and running, but again, there's no cron event to make sure that pmcd is up and running. So there's no cron event for that one. All the archives are going to go into varlog PCP pmlogger, whatever the name of the host is. And then there's a pmlogger daily to clean up that directory. And you got to make sure that these cron events have a proper permission, 600. That's it. I'm not going to go any further in this module. CSA and accounting will be optional on our own. Let me just go to the end here. So, lab tasks. One of the things we got to make sure is that my timestamps are all accurate, that we're all on the same time zone and within a few minutes of each other. Make sure that syststat is installed and set up the SAR command like syststat for 31 days. Make sure PCP is installed. Determine what metrics are available. Configure the archives and get a pmlogger collection going. And set up PMIE. That's all that you're doing. We are not going to do any CSA stuff. So my labs, lab assignment, all of the inventory lab, and then also the instrument with the SAR and PCP only. I'm just finishing up here.
Are the lab pages the ones on the website, Dave, for the UV page that you sent out?
Okay. What about them?
Are they going to be the pages up on that UV website that you sent out, which was all of the UV training materials? Are the manuals and the labs going to be on there from there?
Yes.
Yeah. Okay.
So you've got it on the DVD that I sent, and it's also, there is a course presentation. Let me get to that in a second. So you're going to go up to page, you're going to do all Module 2 and then Module 3 up to page 3.5. Stop at page, lab page 3.6. So we don't need to do any CSA stuff. Now let me share my desktop here. And let me see if I've got it here. First of all, let me get out of here for a second. Hang on. So here is this particular course offering. So I had them grab, here's the hours and stuff like that. So here's one set of materials, including, let's just check here, there's my instrument, the system lab. These would be the PDFs. And I'm just checking. So it looks like that one, for example, does not have the check config pmlogger on added to it yet. Looks like I missed it in this one. The snapshot, let's see what do we got for a date here. 1206 is what I see there. Now the other place that I have information now, www.tng-daw/SGI_UV. This is what was mailed to you on the DVD. So this, again, www.tng.americas is my web server, ~DAW, and then this is the SGI_UV directory, which is what was burned for you on the DVD that got mailed to you. And in here then, the second one is the system analysis thing. I need to warn you, if I expand in this area, it's giving me the tasks, but I have not linked those tasks to anything yet. I have not actually created individual files, MP4s for each individual task yet. But if I click over here, let's see, instrument the system. Let me go to the labs here, and let's just see what we got there. And SAR, PCP. And that one is also still a little bit old. That's still the 12.6/2012 version of the manual. So it looks like I am slightly out of sync here. But again, if I go into here, instrument the system, I can click in here and then be able to get a recording from a given class that I've had in the past. And I'm not guaranteeing that they're going to match everything. So some of them might be 3 years old, but the concepts in the lecture are still basically the same. So with that DVD, at this point, when you expand everything, you'll see the tasks that I want you to be able to do, but they won't click to anything yet. And then some of these other things will have an NA saying if I click there, there's nothing there. So this is kind of a proof of concept. Again, I go through a lot of stuff in the class, and recording them and providing them back to you is convenient. When this class is done this week, I will be giving you recordings from this week as well. I do not mind if you share this DVD with other people. I just don't want it posted on the web. I like to call these things a bootleg. Recorders going, they have not been edited. Some of them I might take a 15-minute break and the recorder's still going. So I don't consider this something that I would be selling, just something that is helpful for people to refresh their memory on the particular UV classes. Did that answer your questions good? I'm not hearing any comments. Okay.
Yeah, we got that. Yeah.
So your DVD that's sent should still have a January 28th timestamp on it. And as I, update things and edit and stuff like that, this will be the web page that I burned the latest version off for the next class, for example. But I need to spend a couple months and go through and actually edit these things and get rid of typos and brain-dead comments and stuff like that.